for 0 to 2 pi. So this has been added. Sorry, when I made your photocopies, this wasn't on there. It says for each graph, identify the starting point and indicate the direction of motion with arrows. So this is really important because this is going to be on your quiz. We're going to ask you to indicate the starting point and the direction. So you need to add this into your notes sheet. Okay, sorry about that. So let's see here. It says r equals negative cosine theta. So I'm hoping some of you right away could go right to the rectangular equation for that, right? So you could just tell me what that equals. If you can't, you're going to have to do the long conversion if you want to. But notice this is a cosine curve, so the graph of the circle is going to be on the x-axis. It's a negative, and 8 is the diameter. So we don't have enough room here, so I'm going to go 2, 4, 6, 8. Actually, I'll use black. So this is a negative 8. These are all negatives, sorry. So there we have it. My center has to be at 0, 4. My radius then is 4 units, so 2, 4, 2, 4, 2, 4. There's my graph, right? But I need the starting point and the direction, and I can only get a starting point and a direction, or just the starting point really, if I tell you where your domain is, where we're starting. So we're starting at 0. Right? So you then want to say to yourself, okay, I need to do a quick little sketch of what that cosine curve looks like. Well, if we have a negative 8, that means we start at negative 8 down here, we go to positive 8. So my cosine curve goes from negative 8 to positive 8 and back down again. Okay, well, that makes sense. So my starting point is at 0 radians, which is right here. I start at a negative value, which is over here, negative 8 units away, because I have to go the opposite direction, right? So, oops, if I was here, then I have to go over here to this direction. Okay, so this right here is my starting point. Now, as I rotate through the first quadrant, as I rotate through here, all these values are negative, which is why all of these values are down here in the third quadrant, because as I rotate through the first quadrant, it's actually producing values in the third quadrant. As I continue, so that takes me all the way to here. Then I continue in my second quadrant from 0 to pi over 2 to pi, sorry. That's going to take me going this direction. So all I have to do is indicate the direction. And once again, the second part here would be my second loop. Second loop around the circle. Now I didn't finish my rectangular equation. You don't really need to. It didn't ask, did it? No. Oh, yeah. So then convert to rectangular coordinates. So here, if you were doing that, well, my center's at negative 2, 0. So that's x plus 2 and then y squared. And my radius is 2. So then that's why I have 2 squared, which is 4. Okay, I would try the next one on your own. Pause now and try letter B on your own. Okay, so does your graph look like mine up here? Was the circle on the y-axis? Oops, sorry about that. Was it on the positive y-axis? Remember, if this is the diameter, then your center is going to be at 0, 5. So here's my rectangular equation. You know, if you don't understand this rectangular equation, you can always build it. You want to look at the notes to help you build it. It'll be a little more clear. My starting point, so here's my little graph up here of this sine curve, right? It's a positive 10, so I'm going to start by increasing. So my starting point, though, is right here at 0, 0. So my starting point is 0, 0, and then through the first quadrant, I'm doing positive radius, so it's just rotating right through the first quadrant. So there we have the direction, I have my arrows, I have my starting point, and that's all. Now this little side note you should make note of, it says how would these graphs change if we graphed over the domain? Pi over 2 and 3 pi over 2. So if we change the domain to pi over 2, 3 pi over 2, well the graph of the sine curve looks like this. It looks like a negative cosine curve. So we start at negative pi over 2. Well, that's rotating backwards, negative pi over 2. And notice my radius is negative down here, which means I'm going to flip up here. So the only thing this would do is it would change what? It would change the starting point. That's all. So it would change the starting point, because now instead of your starting point being at 0, 0, my starting point with this new domain would be at the top. because it's a negative pi over 2, which means I rotate backwards. It's a negative radius, so I'm going to go up here to 10 on the other side. Everything else would be the same. The direction that you would rotate would be the same. It would loop twice. All that would be the same. Okay? Record. That's okay, so the next thing we do is ellipses. Oops, did I skip something? No, I didn't. Sorry. Okay. So my ellipse, it just says, oh, sorry, not ellipse yet. Sorry, it's example 5. So convert the polar relation r equals 6 cosine theta plus 4 sine theta to Cartesian coordinates. So this time I'm trying to make my r's and my thetas go away and replace them with x's and y's. And if you recall, we do that by saying x equals r cosine theta, y equals r sine theta. So I'm trying to get r cosine theta and r sine theta here, but I don't have r cosine theta or r sine theta. I just have cosine and sine. So in other words, I need to make an r cosine theta so I can multiply that entire parentheses by r, but if I multiply the left-hand side by r, I have to multiply the right-hand side by r. Well, that's awesome, because the other thing we know is that r squared equals x squared plus y squared. So on the left-hand side, r times r is r squared. And that's exactly what I need to get it in terms of x and y. On my right-hand side, I have 6r cosine theta, and I have 4r sine theta. So now I'm just going to replace, well, r squared is x squared plus y squared. R cosine theta is x. R sine theta is y. So technically you're done. You can move everything to one side. And this is your rectangular form. Now, if we said find the center and radius, then you would need to complete the square. So if you want to practice completing this square, please pause and go ahead and do that and see how you do. If you complete the square to find the center, you should get a center of 3, 2, and the radius equal to square root of 13. So try it and see if that's what you get. All right, moving on to ellipses. So the equation for an ellipse looks much like the equation for a hyperbola, except instead of a minus sign in between, we have a plus sign. So the order in which, because it's a plus sign, we don't care if you put the x squared first or the y squared first, it doesn't matter. It's totally up to you. You can always put x squared first and then y squared. You find your center, hk, the same. We have minor axis and major axis. It really doesn't matter if you call it a minor axis or major axis. You can see the major axis is the longer axis. So if it's more wide than it is long, then of course your larger number is going to be below the x, and if it's more tall, then your larger number is going to be below the y. But the significance of the a and b is not important to us right now. So you don't need to worry about which one's a squared, which one's b squared. We really don't need to know that. If you look at example 6, we're just going to go ahead and graph. So if we graphed this, my center is 3, -1, right? So I go to the right, 1, 2, 3, down -1. And then this represents a squared, so a is 4. So I'm going to go to the right, 1, 2, 3, 4, because that's my horizontal dilation. Left, 1, 2, 3, 4, because that's my horizontal dilation. And then my y, we take the square root of 4, so my b is equal to 2. That's my vertical dilation, so I go up 2, down 2. And then you just do your best to make a smooth curve around there. So there's my ellipse. So that's letter A. Why don't you pause now and try letter B on your own? Okay, so did you get your second one where you have a center of -4, 3? If there is no denominator, then what is your denominator? It's 1. right? So we're going to move right and left 1. We're going to move up and down 3. And so your ellipse should have looked like this in the second quadrant. Okay, I recommend you do example 7 on your own. You should be able to complete the square and graph it. So go ahead and do that. All right, so did you get a center of 2, 1? Sorry, the major axis is vertical axis is the major axis. But we're not really going to ask you about that. But so that means it was more tall than it is wide. When you did your division here by 50, this is not a perfect square, but that doesn't matter. You're just doing an approximation. The square root of 9 is 3. So if you didn't have your calculator, you just say the square root of 10 is a little bit more than 3. Right? The square root of 25 is 5, so you go up and down 5, right and left 3, and or 3-ish, more than 3, and then you connect it, and there you have it. I would pause now and try the rest on your own, and then come back and check your solutions. So moving on, you should still be able to do this last page, no problem, right? So try this. Complete the square, try to come up with the equation, and then when you are done, check your answers with me. So pause. All right, so have a look. Did you get a center of 5, 5 for this ellipse? Hopefully you did. And then you had a horizontal dilation of 2, so right and left 2, 1, 2, 1, 2, up and down 1. And so this is what your ellipse should have looked like. Down here for exercise 8, did you get your center here, which is to the right 1, up 2? So we have right 1, up 2. We count to the 4 right, so that means we square it, or you could just leave it like this. If you do x minus 1 divided by 4 squared, and then we go up 2, so you could either square it and make it 4, or you could leave it like this. So either of these forms right here are fine. It doesn't matter. Sorry, so I didn't want to show you those. So the next ones, if you didn't do them, pause and try this on your own. We'll do maybe the first couple, and then you should try the rest on your own. So this first one, you don't need to do any calculations for this. You're just doing it by inspection, right? What is it going to be by inspection? So if the x is positive, x squared is positive, first of all, if it has an x squared and a y squared, then it has to be a circle or a hyperbola or an ellipse. If you have a positive x squared and a negative y squared, or one's positive and one's negative, it must be a hyperbola. If you have an x squared and a y squared, like number 2, but it's a positive in between and they have different values, that means it's an ellipse and not a circle. For letter C, you can see it has a y squared but only an x, which means it has to be a parabola. So pause and try the rest on your own and see how you do. So, did you get the answers I have posted?